number 1. And then probably the first few are things that you've seen before, but the later ones you may not have. Okay? So number 1, the most famous one, sine squared of x plus cosine squared of x equal to what? Equal to? 1, yes. Sine squared plus cosine squared is equal to 1. And this is often used in 2 different forms. One is sine squared. If you solve this for sine squared by subtracting cosine squared to the other side, you can say sine squared is 1 minus cosine squared of x. And cosine squared of x is 1 minus sine squared of x. So sometimes you want to change the sine squared into 1 minus cosine squared. Sometimes you want to change cosine squared into 1 minus sine squared. And when do you use this, not the other? Well, we'll have to see examples to talk about that, okay? Right. So second one is you can express all the other trig functions just using sines and cosines. That's the fact. So if you use tangent of x, if you use sine and cosine to represent tangent of x, how do you do that? Yes, sine over cosine. How about cotangent of x?
Cosine over sine.
Cosine over sine, because cotangent is the reciprocal of the tangent, right? So it'll be cosine of x over sine x. And then you also have to remember the 2 reciprocal functions. So cosecant of x is defined as 1 over what? 1 over?
Sine.
Sine, good. And secant of x, of course, the only one remaining will be 1 over cosine x, right? Okay. So these are the formulas that you absolutely have to remember. You have to memorize them. And additionally, and now here comes the formulas that some of you may not have seen before. I thought everyone would learn this in high school, but I then later realized that some schools they skip some parts of algebra 2 or pre-calculus, and you don't get to see this. Well, I'm just curious, does anyone know the formula for sine A plus B? It goes like sine of A cosine of B plus sine of B. Let's write cosine. Cosine of A, sine of B. So some people say sine of B cosine A or cosine A sine B because multiplication is commutative. Either way is the same. Now, let's think about this next one. Oh, by the way, this one can be proven geometrically. So, yeah, but it takes a while. So, if you're curious, just watch some YouTube videos that has geometric proof of sine angle sum formulas. It's not too bad. Okay. Now, if you accept this one, then you can go to this. You can figure out sine of A minus B in the following way. Just replace B by negative B. Okay. If you replace B by negative B, this is going to be negative B. And this is going to be negative B, right? Is cosine negative B equal to negative cosine B or just positive cosine B? Do you remember that?
It's just negative, right?
Here's a cosine graph. Messed it up. Okay. So if you have x and negative x, what can you say? Cosine of negative x and cosine of x, are they equal or of opposite sign?
Of opposite sign.
This is the value, right?
Oh.
This is the value.
Okay.
They're of the same sign, right? On the other hand, if you look at the sine graph, this is a sine graph. Oh, by the way, it's okay not to know these. Okay? What's not okay is not being able to remember that this is the cosine graph and this is the sine graph. Okay? That's an absolute must. Okay? So if your trigs are not good enough, then I sent you an email last night with the links of my videos that has basic explanations of the graphs of sines and cosines, right? You absolutely have to review them. Okay? We can't do it here. It's already calculus 2. All right, so over here, if you have x and if you have negative x, what do you see? For the sine graph, sine of negative x and sine of x, do they have the same sign or opposite sign?
Opposite.
Opposite sign. So for the sine, negative comes outside, whereas the cosine, the negative is eaten away, right? So these functions are called even functions. These functions where negative comes out, those are called odd functions. Sine is an odd function, cosine is an even function. Okay? So here's what happens. If you replace b by negative b, this has no effect because cosine negative b is same as cosine b, right? So you have sine of a, cosine of b, it doesn't change. I'm supposed to write cosine negative b, but negative I can just get rid of, right? But how about this one? Sine of negative b. That negative, according to what we just figured out, that negative can be brought outside, right? So it's going to be negative cosine of a sine b. And then you have a similar formula for cosine and cosine a minus b. Cosine of a plus b is cosine A cosine B minus sine A sine B. And then cosine A minus B. Let me see if you understood what I just said. So what would happen to cosine A minus B then? Yeah?
Wouldn't this be cosine A cosine B plus sine A?
That is perfect. So the only change is this minus becomes plus, because when you replace b by negative b, that negative comes out, and negative of negative is positive. Right? All right, so hopefully the ones with negatives are not a problem, but you absolutely have to memorize this addition ones. Okay, you have to memorize sine A plus b and cosine A plus b.
Thank you.
Seeing the proof helps, but it's not really necessary. You can just memorize these two. Okay, now I'm going to write further important equations, but I'm going to put item 4, 5, and 6, but everything I write on the right side shouldn't be memorized. It should be derived from the left side. Okay, so that and you should make it as a habit. Right? Anything you don't have to memorize, it's better not to memorize it, because when you derive, you get to practice more math, right? Algebra, and also it reinforces what you already know. So it's like even better for you than just memorizing it. Okay, so the first thing is, what would be sine 2a? Well, sine 2a, if you think about it, would be if b is equal to a, right? If you replace b by a, what is a plus a? 2a, right? So that's what you're going to get. Okay? Now, according to this formula right here, if b is replaced by a, what would you get here? Sine a times cosine. Did you not hear what I just said? b is replaced by a. Okay? So sine a times cosine a plus
Cosine A.
sine a, right? Oh, but they're the same thing, right? Cosine A times sine A is same as sine A times cosine A. Multiplication is commutative, right? So you're adding the same thing over again. That means you can combine them, right? So what would you get on the right side? 2 sine A cosine A. Okay. Cosine 2A. What about this one? That would be this formula right here, right? But instead of B, you place A. Right? So what does the right side read? Can you say?
Cosine A, cosine A.
Which is like cosine A squared, right?
Right.
Okay. So this squared minus?
Sine A squared?
Yes. Now, however, it's a custom, or you would say shorthand, that when you have this, mathematicians don't write it like this, they just write it like that, because that way you don't have to put all these annoying parentheses. It's less confusing sometimes with less parentheses. So that's how it's written. Okay. Now we are going to apply this identity here. Sine squared is 1 minus cosine squared. So let's see what happens. Cosine squared of A minus sine squared is, you know what, let me write it on this side. Okay, so if I replace sine squared by 1 minus cosine squared of A by using this identity here, right? Then negative of negative is positive, and this is same as that one, so that doubles, right? Following? Right? That's not so hard. However, what if we took this thing and instead of replacing sine squared by 1 minus cosine squared, what if we replace cosine squared by 1 minus sine squared? What would that be? This would be 1 minus sine squared A minus sine squared, right? And since these two are the same, you're going to end up with 1 minus 2 sine squared of A. So maybe I should highlight the ones that are important. Okay. And your goal is to actually not try to memorize this. Rather, you want to derive it. Okay? Doing exactly the same kind of calculation. But not by writing it out, but actually just thinking everything through. Okay? So you have to be able to write this just from mental math. So we'll try to practice that after this. Okay? So we'll try that. Okay, number 5. Since 2 cosine squared minus 1 is cosine 2a, so this is equal to this. You can solve this for cosine squared of a, right? What will be the result if I solve that for cosine squared of a? Are you good at mental math? Can you try it? It's not that hard. So this equal to this, I want you to do the mental math to solve for cosine squared of a. Okay, and the hint is that you're going to have a 2 in the denominator. What goes in here? What's the numerator?
Just 1.
Huh?
Just 1, right?
No, there's this one. This is equal to this, and you're solving for cosine squared. What do you get?
Negative cosine 2a?
No.
Negative sine A.
Let's do it.
1 minus sine squared.
Cosine 2a equals to 2 cosine squared of a minus 1. Okay. I'm trying to isolate this one, right? So what do you do first?
Oh, plus 1.
And then you divide by 2, right? So you get cosine 2a plus 1.
Oh.
Okay. How about sine squared of a? So now this time you're solving this equal to this. But instead of dividing by negative 2, I want you to have it in the form where the denominator is 2. What's on the top if you do that? Still calculating?
Sine squared A minus 1.
No, you have cosine 2a equals to 1 minus 2 sine squared of a, right? You're solving for sine squared of a. What do you get? Hmm?
Which you minus 1. Divide by.
Okay. Okay, number 6. So this last ones are what's called the product to sum formulas. And it's a way to rewrite the products of two trig functions into sum of two trig functions. And here's how what it looks like. Let me just write it. Sine A cosine B is 1/2 sine A plus B plus sine A minus B. So that's what you do if a sine function and a cosine function is multiplied. Now normally when you look at the formulas for products of trig functions, they have another formula for cosine times sine, but that's not really necessary. Anytime sine and cosine is multiplied, even if you see cosine something times sine something, you can switch places, right? And then you can write it like that, right? So when sine and cosines are multiplied, this is how you make it into a sum of two different trig functions. Cosine A, cosine B. If you have cosine and cosine multiplied, then it's going to be sum of cosine A plus B plus cosine A minus B. And then for the sine, if you have two sine functions multiplied, then it's going to be negative 1/2 sine A plus, cosine A plus B minus cosine A minus B. And then you have to know these. You have to know everything in here. Yeah, what's interesting is that I don't give out any formula sheets, so you actually have to know them. On the other hand, since I'm not giving a formula sheet, anytime you recite something that's correct, that's partial credit. So that's the good part. Okay? But this already looks very scary, right? Number 6 looks really scary. How would you memorize this? Well, again, the trick is not to memorize them. You can prove it. Yes?
Because like it's half of the number.
Very good. Yeah. So you already saw it, right? So if you add these two, what happens? This is plus, that's minus, so these are going to cancel, right? But this is going to double. So what do? You add them, and it's double, so you want to get rid of the double. how do you get rid of the double? By putting a 1/2. That's how I do it. Okay? So rather than trying to memorize it, which is really confusing, just prove it. You can actually mentally think about these two, right? And then just add them. Oh, these are going to cancel. What am I going to end up with? Sine A cosine B will be doubled, so you take half. Done. Right. Then you look at this one. Because of the way that cosine A plus B looks, if you add the cosine A plus B and cosine A minus B, again, this part will cancel, and you get cosine A times cosine B doubled. That's why you put a 1/2 in there. And lastly, this is actually the only thing that I memorize. So, and I really mean that. I actually don't have all these memorized. I just prove it on the spot. Do you think I always try to memorize this? Every morning I wake up and I have like list of formulas to memorize for my math class. It doesn't work that way. Okay? It's just very natural if you prove it. It's just obvious. So here, but there are like a few parts that you really want to memorize, because without it, then you lose track. Okay? So I kind of tend to memorize there's a minus here. Okay? And that minus comes from the fact that if you do this minus this, these two cancel. But because you're subtracting this, this is not twice of sine A sine B, but it's actually -2 times sine A sine B. So when you divide by -2, there's a negative that happens. So that's the only thing that I memorize. Everything else is just natural. And I will be giving you some time to practice this, and then after this we'll look at some examples that we use these formulas for integration.